Hello everyone, welcome back to my channel. So in this video I'll be explaining you how to solve problems related to minor losses. So before watching this video, do watch my video where I've explained different types of minor losses that occur in a pipe flow. Okay, so I have discussed the formula there. So now let's solve some numericals related to minor losses. So see the first question. Find the loss of head when a pipe of diameter 200 mm is suddenly enlarged to a diameter of 400 mm. The rate of flow of water through the pipe is 250 liter per second. So it's given that the pipe is getting suddenly enlarged. So this is the case of sudden enlargement. Okay. So initially the diameter of the pipe was 200 mm and later it got enlarged to 400 mm. So this falls under the case of sudden enlargement, which is a possible case of minor loss. The discharge is also given 250 liter per second. He is asking us to calculate head loss. So if you remember, the formula for head loss for sudden enlargement was V1 minus V2 whole square by 2g, where V1 was the velocity before enlargement and V2 is the velocity after enlargement. Okay, but we don't know the values of V1 and V2, right? It's not given in the question. So that's the reason they gave us the value of discharge. So from discharge, we will calculate V1 and V2, then we will proceed with calculation of head loss. So let's start off with the given data. Diameter of smaller pipe or D1 is 200 mm, which is 0.2 meters. This is 200 by 1000. Next, once you know the diameter, you can calculate A1 as pi by 4 D1 square, which is pi by 4 of 0.2 square, which is 0.0314 meters square. Next, diameter of larger pipe is D2, which is 400 mm. That is after enlargement, which is 0.4 meter. So area will be pi by 4 of 0.4 square, which is 0.1256 meters square. Then given to us discharge or rate of flow is 250 liter per second, but we should convert this into meter cube per second. So just divide by 1000. So it is 0.25 meter cube per second. So we have a formula Q equal to A into V. So from here V1 is Q by A1. So it's 0.25 by 0.0314, which is A1. So we'll get 7.96 meter per second. Similarly V2 is Q by A2. 0.25 by A2 is 0.1256. You get 1.99 meter per second. So now we can take up the formula of loss of head due to sudden enlargement, which is V1 minus V2 whole square by 2g. Just substitute and we get 1.816 meters of water. This is how we need to calculate the problem related to sudden enlargement. Now let's see the next problem. The rate of flow of water through a horizontal pipe is 0.25 meter cube per second, means what? Discharge is given. The diameter of the pipe, which is 200 mm, is suddenly enlarged to 400 mm. Okay, again this is the case of enlargement. 200 mm pipe is getting enlarged to 400 mm. The pressure intensity in the smaller pipe is 11.772 Newton per centimeter square. So pressure in the pipe is given, which before enlargement. So he is asking us determine loss of head due to sudden enlargement. Like in the previous case, you need to calculate HL value or HE rather. Next, pressure intensity in the larger pipe. Now you need to know the value of pressure of water in the enlarged pipe. Next, power lost due to sudden enlargement. Okay. So now up to here, up to question 1 you can solve. Why? Because it's very similar to the earlier model which I have discussed. The remaining two are new now. So discharge is again 0.25 meter cube per second. D1 is 200 mm, which is 0.2 meters. A1 is pi by 4 of D1 square, which is 0.0314 meter square. Next, D2, enlarged pipe diameter is 400 mm, which is 0.4 meters. Again, A2 will be pi by 4 of 0.4 square, which is 0.1256 meter square. Next, P1, pressure in the smaller pipe, means before enlargement is 11.772 Newton per centimeter square, but you need to convert this into Newton per meter square, so multiply with 10 power 4. You can just check my earlier video where I have discussed about numericals on Bernoulli's equation, where I have shown how do you get this 10 power 4. Next, so V1 is Q by A1. Again same value. V2 Q by A2. You got 1.99 meter per second. Let's calculate loss of head due to sudden enlargement. V1 minus V2 by whole square by 2, which is the formula. We got 1.816 meters. Now let's calculate pressure intensity in the larger pipe or the enlarged pipe. We don't know its value. Let it be P2. Now we should start applying Bernoulli's equation. Why? Because we have two pipes, two sections before enlargement and after enlargement. So the formula for Bernoulli's theorem is P1 by rho g or P by rho g plus V square by 2g plus Z is constant across any section. When you are applying for two sections, if you take real fluid, it is P1 by rho g plus V1 square by 2g plus Z1 equal to P2 by rho g plus V2 square by 2g plus Z2 plus loss of head due to enlargement. But this is a horizontal pipe, so Z1 and Z2 are equal, so they will just cancel out. You will be left with P1 by rho g plus V1 square by 2g equal to P2 by rho g plus V2 square by 2g plus He. Now let's substitute whatever values we have. What is that we need to calculate? Only P2, right? So just substitute. Okay, I brought P2 by rho g this side. All the terms all on the right hand side. Just substitute all the values we have. We got P2 by rho g as 13.21 meters of water. This is pressure head in the enlarged pipe, but he asked pressure only. So this rho g will go this side. So 13.21 into rho g. Rho means 1000. Density of water 9.81 is g. So finally we got 12.96 into 10 power 4 Newton per meter square. But if you remember in the question, our P1 was given in Newton per centimeter square. But for our convenience, we converted into Newton per meter square. But now also you should convert or indicate P2 in terms of Newton per centimeter square. So just divide by 10 power 4. You'll get 12.96 Newton per centimeter square. Okay. And what is the third question given to us? Calculate power loss. So power loss formula is rho g QH by 1000. Okay. So how did you get this formula is, you can just check out my earlier video where I've discussed power transmission through pipes. How you get the value of power formula. Okay, just take up read that video or just go through that video. Now just substitute. We have rho, we have G, you have Q, you have He. Substitute, you'll get the value of power lost, which is 4.453 kilowatts. Why? Because we divided with 1000. Clear? This is the second model of question where pressures are given. Let's see the third model, mostly expected model. A horizontal pipe of diameter 500 mm is suddenly contracted to a diameter of 250 mm. Now this is the case of sudden contraction. So 500 mm dia pipe is getting contracted to 250 mm dia. The pressure intensities in the larger and smaller pipe is 13.734 Newton per centimeter square and 11.772 Newton per centimeter square respectively. So in the bigger diameter pipe, the pressure is 13.734, and in the contracted pipe, which is 250 mm, the pressure is 11.772 in Newton per centimeter square. Find the head loss if Cc is 0.62. So here, coefficient of contraction is given to us. Is also asking determine the rate of flow, means you require loss of head due to sudden contraction, Hc along with Q. Now let's start off with the given data. If you remember in my video where I've talked about minor losses, I discussed two formulae for loss of head due to sudden contraction. One formula is when Cc is not given, one formula when Cc is given. When Cc is not given, we have direct formula 0.5 V2 square by 2g. That is after contraction. But if Cc is given, I have given another formula. So just check out that formula. I'll be showing here also. So let's start off with the given data. D1, larger dia pipe is taken as D1, 500 mm, which is 0.5 meters. So A1 is pi by 4 of 0.5 square, which is 0.1963 meters square. Similarly, D2, which is the contracted pipe or smaller pipe, 250 mm is the dia, so 0.25 meters. A2 will be pi by 4 of 0.25 square, which is 0.04908 meters square. Next, pressure intensity in the bigger pipe is given, that is before contraction 13.734, convert into Newton per meter square, so multiply with 10 power 4. Next, pressure intensity in the contracted pipe is given 11.772 Newton per centimeter square, again multiply with 10 power 4. Given coefficient of contraction 0.62. Now, head loss due to contraction when Cc is given by the formula Hc is equal to V2 square by 2g into 1 by Cc minus 1 whole square. Okay. Now, from here, just substitute Cc value. So, V2 square by 2g into Cc is 1 by 0.62 minus 1 whole square. We got 0.375 V2 square by 2g. Okay. Yeah. Now, we require the values of V1 and V2, right? But here, it's difficult to calculate V1 and V2 at a time. So not like in case of sudden enlargement. Now let's see how to go with. Let's take continuity equation. Why? Because whatever water entered from enlarged pipe only got contracted into smaller pipe. So same discharge is flowing in bigger pipe and contracted pipe. So A1 V1 equal to A2 V2. So from here, what can I write V1 as? Send this A1 that side. It will be A2 V2 by A1. Substitute the value of A2. We don't know V2, let it be V2 by A1. Substitute the value of A1, which we have calculated here. Right? A1, A2 here. Using dias. So you got V1 as 0.25 V2. Now wherever I get V1, I'll start substituting 0.25 V2 such that only V2 will be the unknown. Now let's apply Bernoulli's equation since pressures are given before and after contraction. So P1 by rho g plus V1 square by 2g plus Z1 equal to P2 by rho g plus V2 square by 2g plus Z2 plus Hc. This is head loss due to contraction. As usual, the pipe is horizontal, so Z1, Z2 will get cancelled. You will be left with P1 by rho g plus V1 square by 2g is equal to P2 by rho g plus V2 square by 2g plus hc. In the place of P1, substitute the value. Rho is 1000, G is 9.81 plus V1. Just now I told you, in the place of V1, you need to substitute 0.25 V2. Substitute here 0.25 V2 whole square by 2 into 9.81 is equal to P2 value is there. Substitute. Rho is 1000, G is 9.81 plus, in the place of V2, just put V2 only, by 2 into 9.81 plus hc. What did we get? 0.375 V2 square by 2g, correct? So 2 into 9.81. So once you simplify this, we got V2 as 5.467 meter per second. Why? Because if you observe this entire big equation, we have only V2 unknown. So V2 is 5.467 meter per second. Once you get V2, you can substitute and get V1 also, but that's not required for time being. Our question is all about calculation of head loss due to contraction. So HC, take up this formula, 0.375 V2 square by 2g. So it will be 0.375 into V2 means 5.467 square by 2 into 9.81. I got 0.571 meters. Then you can calculate discharge by using the formula A to V2. Okay. So that's how you need to solve problems on minor losses. Hope you understood this video. If you want the notes of this, just click on the description of this video. You'll get a link. Click and download the notes through that link. Okay. So hope you understood, and thank you.